So, welcome to the first lesson. Today, we are going to discuss just a little bit of a review on proportional relationships. So, on your standards, that will be this 8.EE5. So, graph proportional relationships, interpret the unit rate as the slope of the graph, compare two different proportional relationships represented in different ways. The notes that I'm going to show you will mostly focus on the compare two different proportional relationships. We'll look at what graphing these looks like at a different date. I may add another video here discussing that, but for now, let's look at and review proportional relationships. So what I've done is just brought in some notes from 7th grade. I told you I used to teach 7th grade. So here's the overarching question. Look, how to determine proportional relationships. Is the data, are the numbers given to you, are the relationship given to you, is it proportional or not? So that question will be applied to four different types. So here's four boxes. I'm going to remove these one at a time, and you might get a graph given to you. So if you'll remember from last year, if a proportional relationship is given to you on a graph, it's really simple to decide if it's proportional or not. The graph is going to have to be a straight line. Okay, and notice how I put a box around and. A straight line is not good enough. It's got to go through the origin, which is the ordered pair 0, 0. Okay, so here's just a couple of sketched examples. Here's the coordinate plane, an x-axis and a y-axis, and one example could be a straight line going right through this origin. All right, if I just give you one quadrant of a coordinate plane, straight line going through the origin, it doesn't have to go like this. It could go sloping down, but as long as it's straight line going through the origin, it is a proportional relationship. 9 examples. Obviously, if it's a curved line, it doesn't fit this first criteria of a straight line. So that's not proportional. That is a straight line, but it does not go through the origin, so it is not proportional. The second way we can determine proportional relationships is through tables. So I'll move that over, and you're going to have tables. And if you want to figure out what the constant of proportionality is, or the unit rate, that's the same thing, you simply divide your y value by your x value. So here's a couple of examples. So y divided by x, 2 divided by 4 is 1/2. 4 divided by 8 is 1/2. 6 divided by 12 is 1/2. So this is proportional. Why? Because that unit rate is the same all the way through this table. So it is proportional with a unit rate or a constant proportionality of 1/2. Here's a non-example. When you divide y by x, you get 10 divided by 4, which is going to be what, 2.5? You get 20 divided by 8. And all the way through here, it looks fine until you get here and it's like, 100 divided by 25 is 4. So this does not have the same unit rate all the way through the table. Folks, that is not a proportional relationship. Okay, so that's from tables. Hopefully this is a review for you. It should be. You might also get ordered pairs and be asked the same question. So again, you're just going to divide the ordered pairs, y and x. So ordered pairs are set up as y value, x value. So in this example, the 1 is the x, the 4 is the y. So 4 divided by 1 is 4. 40 divided by 10 is 4. 80 divided by 20, or y divided by x, is 4. That is the same unit rate all the way through there. It's 4. And I can use these unit rates to compare. If I'm asked to compare different proportional relationships, well, if that one's got a unit rate of 4 and this one up here going back has a unit rate of 1/2, I can compare that. Okay, so that's got a smaller unit rate than 4. A non-example, so if I do y divided by x, I can get the unit rate to be 2, and then all of a sudden I do 15 divided by 3 and get the unit rate to be 5. That's not the same unit rate. This can't be proportional. And then our last form would be from equations, and this is the biggie. So let me check my time. I've got about 45 seconds or so to go over this. So from equations, every proportional relationship is going to be in this form, or have the ability to get in the form y equals some number x. You may have been taught the form y equals kx, where whatever this number is right here is the unit rate or the constant proportionality. Now, it may have different variables. It could be k and m. It doesn't matter, but whatever that is the unit rate. So y equals 2x would have a unit rate of 2. C equals 10m is the unit rate of 10. Some non-examples, y equals 2x plus 1.